Hi there. So my name is Mikhail Panchenko, or Mike, or Pancakes is what most people call me. I can tell you the story of why that is some other time. It's way too long. We're far too near to the afternoon break to take our time on that. I'll try not to take up too much of your time, and then we can all enjoy and fantasize together during break. So, I work at a little company called, oh my god, everything's messed up on my screen. 1 second. Yep, I have no idea what that says. All right, well, hopefully I remember everything. So, I work at a little company called Opsmatic, and we started the company on the premise that there's lots of improvement to be had in tools that IT and IT and web operators use on a day-to-day basis. And so, we've been thinking about problems that we'd come across in our collective experience where we felt sort of underserved, like the tools weren't good enough, and that we just were not, we were wasting our time. Things that seemed tedious, things that seemed like they were in the way of actual progress. And the context in which we're thinking about this is that, there's a lot of talk about what DevOps is and isn't. Catherine touched on the problem of people saying, oh, well, DevOps will solve all my problems. I'll just add a DevOps team. To me, and I think to a lot of other people, DevOps is just getting shit done. Doesn't matter what team you're on, doesn't matter what your little business card says, doesn't matter who you report to. You work with the people that you need to work with to get done what you need to done. In the old famous words, you enable the business. And so the problems that I'm talking about are not ops problems or not dev problems. They're problems for technical organizations that are trying to deliver a product. And we'll see, you caught a little bit of, actually Catherine's talk was a great kind of setup for this, because one of the biggest problems that you run into is this sort of divide and this lack of communication and this one hand not knowing what the other hand is doing, and the reason, and this leads to unhappiness. So, as a technical organization, when we're happy, what's happening is our customers are comfortably using our product. Our product is nice, works, and it's evolving, and hopefully it's evolving faster than our competitors, right? And as that's happening, and the site keeps growing, and we keep doing the same thing, virtuous cycle. Everybody's happy. We have time to sort of plan ahead, do all those strategic things, do all the proactive things. Strategic, proactive, roughly the same thing. And when we're sad, the opposite is happening, right? Our product is frequently down or slow. Changes make it worse because, again, more surprises. I would have smiled if I had more notice. But so tech teams spend their time firefighting and being reactive, and not really getting the time to collaborate and talk about all the things that we want to do, that Catherine talked about, and that are strategic. And in this land, surprises are bad, right? And so this is a man that's surprised by what he's discovered. And there's actually a surprise in this photo that you probably won't notice unless you look closely, but look at his index finger. Surprise. Anyway, surprises are the enemy of strategy. There isn't half of his middle finger. That's a surprise, in case you think it's in his beard or something. It's just not there. But surprises are the enemy of strategy. Surprises are what keeps us, keep us guessing. And so, oh, by the way, this is a complete departure from everything we've talked about so far. I'm not going to talk about means or medians or percentiles, but we'll get around to monitoring in just a second. But the point is, we've done a lot to reduce surprises. I'm sure everyone in this crowd is familiar with the sort of state-of-the-art in configuration management. We talked a little bit about Chef doing the OpsWorks demo, and lots of people have put lots of effort into implementing these systems, and a lot of surprises have gone away. However, we're still seeing things like this, where people are still frustrated with just normal things that happen when you use these tools, right? And mind you, we're talking about Cliff here, who had Joe Williams and a bunch of other really smart people, and Joe Williams is certainly no lightweight Chef user. If you know him, if you don't, you should check him out. He knows a lot about a lot. And so here's a guy that's got Joe Williams working for him, and a bunch of other people that are really smart and know a lot about how this stuff works, still completely frustrated and dealing with drift. And this was actually apparently, I don't know because I can't retrace it, an amazing Twitter exchange that John Vincent captured in a blog post. Unfortunately, Twitter doesn't let you unroll the thread that far back in time, but I've linked the blog post, and it'll be clickable in the slides, but there's a lot of the points that I'm talking about here are discussed in a lot of detail in that post if you want to follow up afterwards. But coming back to surprises, it turns out that when you talk about policy, right, you talk about policy-driven configuration management. Policy means that you said, okay, this one thing is important to me. The version of Apache or the version of the software that I've developed myself that is running is important to me. I've explicitly defined it, declared it in this policy, and so the tool will go and happily enforce that for you. However, there's the whole rest of the system that policy doesn't control. And anything that's not in policy can change, can be completely removed, replaced, modified by anyone coming along, and you wouldn't be any wiser. So an example of this, just to make things a little more concrete. So back when I worked at a company called Simple Geo, we wrote a piece of software that was a geospatial index that was straddled on top of Apache Cassandra. And so it had all the nice, it was a flexible index, and it had all the nice properties of a distributed hash table. Of course, it also had all the annoying properties of a distributed hash table, in that it was a pretty complicated distributed system with a lot of moving parts and a lot of surprises. So we started observing this behavior where we had a 9-node cluster, and 4 of the nodes started having this awesome behavior where, it's a JVM process where the stop the world pause would take minutes. Literally like 4.5 minutes, the process would just do nothing. And better than that, you couldn't even SSH to the box during this time. So we had 5 nodes that were doing fine, and none of this was happening, and 4 nodes that were just going crazy. And we thought, oh, well, we're writing this horrendous experimental software on top of software that certainly at the time would have been considered experimental by many, so probably it's something we did. So we instrumented the crap out of the JVM, we added all these log lines, we added all these metrics, we did all the, all these, basically all the things that everyone has talked about earlier today, right? We tried to correlate all these little things, like, okay, well, if I add this, what does it do? Nope, still doing it. And it was an EC2, so we thought maybe it was a certain data center. Nope. Maybe it was a certain underlying processor, which is a familiar narrative. Certain underlying hardware on your EC2 instances will yield surprising results. Nope. Different mixes of all those things on those 4 nodes. So finally, in a moment of exasperation, I ran dpackage-l, which lists all the packages on your system across all 9 nodes, and literally copied them to the same box and ran fucking diff. And surprise, it was libc. A specific version of libc was susceptible to a timer bug only on the modified EC2 version of Zen and nowhere else. The tickets for this are hilarious. The jostling between the canonical team being like, well, what did you change about Zen? It doesn't happen on Zen. And the Amazon team being like, well, we didn't change anything important on Zen that would have affected it. No way. No. So 2 months of my life later, and probably like 15 pounds, because by God, we sat at those screens and watched the graphs a lot. Not a lot of time for exercise. libc. Targeted partial CM runs, which has now become sort of commonplace usage, also yield surprises. Now, what does this mean to the, just in case someone's not initiated? So, configuration management is supposed to run in a cron, and is supposed to enforce your declared policy. It'll run. If Apache is not the right version and you said it should be this other version, it'll say nope and install the right version. Everything's happy, everything is self-healed. Turns out doing that in crons can be quite expensive because the joke is that it stats the whole file system, right? And so people have started only running your CM tools when they need to change something. So let's say you have a web cluster and you roll out a new version of Apache to it. You run, let's pick one. You say you run Puppet on your, it doesn't matter which one, right? But let's pick one just for the sake of the story. And you run it on your web nodes. Great. Then you change some ACLs and maybe some other really important security packages in your base role that should be on all of your hosts. And then you decide to deploy something else to the DB cluster. And so you do that deploy. Now those 2 clusters don't have the same things on them as part of the base role that they're supposed to. surprise, hopefully your web role wasn't the one that got the outdated security-related packages, because that's probably where you're going to get exploited. Changes made during an outage. Literally every single ops team that I've interviewed over the last few months, which is not every ops team ever, but it's a pretty decent sample, everyone turns off CM during an outage. Because the worst surprise is when you're trying to fix the outage and CM runs and undoes all your changes. So everyone's got this muscle memory of, etc init d puppet stop, and then I fix my shit. Turns out a lot of times you do that in the middle of the night. Turns out a lot of times, if we're gonna go a little bit scientific, turns out a lot of times when you do things in the middle of the night, you don't have short-term or long-term memory of this the next day. You just remember that it was a shitty night and you're tired in the morning. A lot of times your friends didn't wake up with you, or coworkers, colleagues, peers didn't wake up at the same time as you. They have no idea this even happened. They're like, where's Johnny? Why isn't Johnny at work? And they, 2 months later, you find out that like 2 of your Cassandra nodes have a completely different heap size setting. Now that's causing other problems that separate from the outage that you were trying to fix by changing those. No one remembers why they're different. And now everyone's afraid to change it back. And worse, you might have had a database outage, and you might have queues that backed up as a result of that database outage. You fix the outage and you say, well, I better burn through these queues. You spin up a node, but you're in a hurry, so you don't spin it up as part of your normal CM cycle. You just spin it up just to get it going. And then you forget that you did that. And then on Monday you come to work and you figure out why the bug happened, and you fix the queue code and you deploy it to all of your queues. Turns out that's not all of your queues, because you have this one that probably forgot about. Surprise, corrupt data. So that sucks. And then the most annoying thing, which we kind of alluded to a little bit earlier, not only do you have the annoying reality of varying underlying virtualization components having an effect on, important effect on performance, you also have literally the same model of the same machine from the same vendor shipping with different settings. And I'm not just talking about, oh, the drive, on the old boxes was from one lot or one brand, and now the drive is from a different brand, but the specs are the same. I'm talking like BIOS settings. And hopefully it's something obvious like, oh, they forgot, on one box hyper-threading was on or off, on the other one it was off, so you'll notice that the number of threads was different. It can be more subtle than that, and you won't know until it's a problem, and surprise. So, I hate surprises. So the $1 million question that helps you A, avoid these situations, and B, recover from them more quickly is, what's different? Right? This can be an incredibly time-consuming question to answer. And we talked a little bit about policy, and you can minimize what could possibly be different by relying on a policy-driven CM tool. But as I just discussed at length, that won't fix all of your problems, and in fact won't fix even some of the problems that it's designed to fix. And a special case of this, which we've also touched on a little bit already, is what has changed. What is different now from Saturday afternoon when everything was fine, right? Like everything was great, now everything's shit. What's changed? And so now we get quotes like this from Chad Fowler of let me see if Sechs Wunderkinder. And what he says is, one of the scariest things I ever encounter is a server that's been running for ages, which has seen multiple upgrades of system and application software. So the reason that's scary is because Chad has no idea what's changed. So much time has passed, and so many people have touched the box and done weird things to it. By the way, the libc example, the reason that happened is because we had one engineer that had the habit of logging onto an Ubuntu box, and the Ubuntu box would say, oh, you have all these packages out of date. You should run system update, whatever updates all of your packages to the current version. And you say, oh, okay, Ubuntu, let me do that. But he only did that to the boxes he logged onto, right? So if you don't know who's touched it or why, and what was on their mind, and why they haven't been fired yet, you immediately sort of, you grow to distrust machines, and as a result, distrust people, because machines, it turns out, don't change themselves. But the cold hard truth is that they do, right? Machines will drift almost no matter what you do. No matter how hard, no matter how good you are at Puppet and Chef. I've been on some teams that invested arguably too much time into into automation and policy-driven CM. In fact, the opposite of the problems that were described earlier, right? Like we actually didn't ship anything. We were so busy automating things, and still we had these problems, right? So what if we just assumed that drift was a natural byproduct of getting shit done, right? Like what if that was just a reality that we embraced and we said, you know what? I'm just going to build my tools in a way that accepts the fact that there's going to be differences between machines. And that's what this talk is all about, right? We're dreaming now. So what even is drift, right? Let's pause for a second and just define our terms before we get too far ahead. So drift is deviation from expectation, which occurs over time. I think that's pretty, I mean, I wrote this myself. I didn't get it off of Wikipedia, but I think it's pretty uncontroversial. Now, expectations is a broad term that includes particularly two things that are very important differences. So there's assumptions, there's things that are sort of the bedrock of you reasoning about your system. You assume that everything in the web cluster will behave roughly the same, and the sort of empirical underpinning of that assumption is that the stuff that's installed on those systems is the same. The extreme case is like if one of your web boxes is running Ubuntu and the other one is running RHEL, you're going to be like, I don't think I can operate in this environment because I have no idea what to expect. But when it's subtle and the differences are smaller, you just kind of assume that everything's going to be fine. Assertions are things that you're targeting specifically, right? You're saying, okay, well, on my dev box, I ran Apache 2.2, everything worked. That's what I'm going to install, and you assert that in your policy management, right? So you can kind of detect those a little more easily. So yeah, the assertions usually make it into policy. Assumptions usually just are assumptions. So the important takeaway from that is that drift happens both inside and outside policy. So, right, so, oh, well, I'm just going to run Puppet is no longer really an acceptable response because, well, we just talked about because. And drift is difficult to find, and I was searching for images for the slide, and I realized that there's no better metaphor for finding that little subtle differences than shaving a yak, right? It's perfect because pretend that on this giant yak somewhere there's a pimple, and it is your job to find it. The only way you're going to find that pimple is shaving the entire yak. And to make the metaphor more concrete, you could say, oh, well, I could figure out what's different. I could diff the packages. Okay. But then there's also kernel settings, BIOS settings, everything in etc, basically. Everything that your running processes reference as a config file, right? Or as anything that could define their behavior. All of that's important. Versions of libc, versions of kernel modules, all of that sea of information, you have to go one at a time and shave the yak. A little strip at a time, and eliminate one thing at a time. And that's incredibly difficult and time consuming, and brings us back to things you don't really want to be doing with your time. Just gets worse. Just stares at you as you go through it. But for a computer, this is trivial because it turns out that computers themselves, all that stuff I just described is a pile of structured data, and lucky for us, computers are excellent at processing structured data. So, if you get computers involved in analyzing computers, you can actually get quite a long ways farther than in just doing it by hand. So drift is also meaningless without a baseline. So you have to sort of have an expectation. And I want to talk about this for just a second because, this sort of naive compare all the boxes doesn't work, right? You have to have something to compare against. So fortunately, baselines are sort of sprinkled throughout our existence, right? So if you're using a policy-driven CM, chances are you have roles or run lists you're using. You're saying, okay, well, this set of servers are running the web role, this other set of servers are running the database role. So a computer can then say, okay, well, these 6 boxes I should assume to be the same, and if they're not, I should flag that, right? So to a computer, that's just cheating on clustering, right? You don't have to actually infer that they're all in the same group. You can cheat and say, well, a human already told me that that these things are expected to be the same. Another form of a baseline is also very practical, basically, on any time you're debugging any sort of weird behavior where you're not sure why a certain node is doing something that other nodes aren't doing. Is what were things like yesterday, or before this behavior started. And if you can go back to a time where things were normal, that's your baseline, and you can just compare. Drift is also meaningless without context, right? The fact that something's different is not actionable. And this is what we talked about earlier. If you showed up on Monday and a bunch of stuff was changed with no record or any sort of documentation, which of course there won't be any because it was an outage. It'll get documented on Monday where no one remembers what happened. So it's not very helpful. But let's stop and talk about what is context, right? What helps you kind of get your bearings straight? So the first and obvious question is what changed? The second question is when did it change? Because then you can figure out what else was happening. That actually is the next question. What else was happening? What were we doing at this time? And the last and most important and often overlooked question is who performed the change? And it turns out that at least in the reality we live in, it's not always trivial because everyone just uses sudo to do everything, and so root did it. But ultimately, if you have answers to these questions, computers won't tell you why something happened, but they can get you pretty close to either the answer or at least the person that knows the answer. Right? So you could say, okay, well, I came in on Monday, everything's messed up. The only person that logged on over the weekend was, Jimmy. Let's find Jimmy and see what he was up to. Oh, and I can also see that Nagios went off at 3 a.m. or whatever bane of your existence alerting software you're using, Xenos or whatever. And I know that at 3 a.m. it went off, and shortly thereafter Jimmy logged on. So Jimmy, what happened at 3 a.m. on Saturday? You can at least track down the right person to ask and do so in a timely fashion. So, what am I even talking about? Why am I here talking about this stuff? I see some nodding. Yes, we're getting there. So this is a monitoring event, right? Well, fortunately, the answer, and maybe some of you have surmised this, is that monitoring is the answer, right? So we're going to get into now, first of all, the fact that monitoring has been asking these questions for a very long time, right? So here's an image from Brendan Gregg's post on using modes to determine, happy and unhappy paths. So, you have one giant set of requests that's taking barely any time at all, and one set of requests that's almost the same, if not larger, that's taking 2 seconds. What's different about those two paths, right? So it's not quite in the same context as I've been talking about, but it still sort of begs the same kind of question. Could be that one is hitting a box that's got libc version 1 or version n, and the other one's hitting libc version n+1. We heard from Etsy already about all the stuff they're doing, and so here's them saying, show me things that are different sooner than I would have noticed otherwise, right? Differences are important. Here's a really old screenshot of Deployinator, which is a little bit of a foreshadow for what we're going to talk about next. But the idea here is that anytime someone deployed something, it was logged as exactly what they deployed, exactly where they deployed it, exactly what time, so that you could put those timestamps on a graph and line them up with things that, terrible things that happened thereafter. And monitoring products are starting to do this more and more. We heard from Joe from Librato earlier. Guess what you can do in Librato? You can hook it up to your CM or CD tools and have it basically mark on a graph anytime anything of interest changes. Now, this is still only focusing on the very specific things that you instrumented, but still sort of starting to get to the same issue of, right, knowing, having the context around a change. So it's not just that the graphs changed, it's that something happened right around the same time. And the fact that something happened is important, and you probably want to know that the moment you start looking at this graph, and not 2 hours later when Mike comes back from the gym and tells you, oh yeah, I deployed that thing at 2 p.m. Mark Burgess did me a huge favor and wrote a book that got released like a month before I had to give this talk. And very few pages into this book, I didn't even, could have even not finished it. There's this awesome page. And of course, Mark's the sort of godfather of modern CM as we know it, and he's digging more in the policy direction, but the point is still very applicable. So what he's saying is control equals predictability plus interaction, and then he says you can simplify that to certainty equals knowledge plus information, where knowledge is a relationship to the history of what we've already observed in the past, i.e. an expectation of behavior, and information is evidence of the present, that things are proceeding as expected. So in order to have a certainty about what's happening, you not only have to have a view of the present, you also have to have a very detailed history of the past that you can examine and compare. Which brings us to the dreaming part. Now we're going to fantasize a little bit. So what I want is ongoing monitoring of infrastructure state, and this is categorical data, hence the title of the talk, right? We're talking about monitoring lists of essentially key value pairs, and if you get deep enough, nested structures. And keep a history, an audit trail that is accessible, that you can navigate in meaningful ways, that you can say things like, okay, well, this particular event happened. What else happened around it? When was the last time this thing happened? What did people say when this thing happened? What were our customers saying when this thing happened? Ability to compare states, and this is the answer to what's changed, and this is both across hosts, as in one node A in a cluster and node B in a cluster, and across time, as in this node yesterday versus this node today. And that's basically finding the pimple, right? That's finding that little tiny thing that's actually different on the vast surface area of the things that could be different. And then put this computer activity, right? Like I said, computers don't just change themselves. Someone did something, right? Maybe it was a sort of a personless agent like configuration management tool, but something somewhere happened to cause the configuration state of a computer to change, and knowing what that something was is critical. And most of the time it's just a person messing around on a server. That's just how it goes. It's usually a pretty simple answer if you're just watching for it. And like I said, a lot of these things are kind of obvious from what the problem statement as I just set it up, but the ability to detect and flag drift. So knowing, being somehow notified, or at least logging that something important that you probably care about happened, right? So inferring that, okay, well, you have 6 web boxes and 5 of them just got a new version of Apache and the 6th one didn't, that's probably not what you wanted to do. Right? And that's actually even worse than just one of them getting a new version, because at least then you can maybe guess that you're trying. If you went for 5 for 6 and forgot the 6th one, you definitely forgot something, right? You want to know when you do that sooner rather than when everything breaks several hours later. Being able to make exceptions, sub-rolls, and roll back your changes. Now, rollback is currently what happens when you're using a policy-driven tool, assuming the change you're making is in policy. Puppet will just come by and say, nope, back to where it was. And if you're actually trying to fix something, again, that's a nasty surprise, right? Because you've just lost whatever it was you were doing for the past 10, 15 minutes to try to restore a site that's probably already down, and the last thing you want to do is try to retrace your own steps, which you didn't write down, because goddammit, the site is down. Why would I write anything down? So exceptions and sub-roles is being able to say, well, I know that this one node is in a state that it shouldn't be in absolutely, but that's okay. Let's just snooze on that for now because I've got stuff to do. Sub-roles is being able to say, look, this is okay. I actually want to keep it this way. Oh, sorry about that. I actually want to keep it this way for the foreseeable future, and then eventually being able to propagate changes across nodes. So saying, okay, you know what? Yes, I did change the heap setting on this one node. I actually want that on all of my nodes, and that's actually the new norm. Now, that's a long way down the page because it's actually really difficult. But the idea is basically being able to integrate with your CM tool such that when you detect a change, you can actually just tell your CM tool, yes, this is what I want. I don't want to go through the normal sort of workflow of, go to my chef repo, find the right file, hopefully I found the right file for the right environment, change the setting, run the full cycle of automation, and hopefully on the other end pops out the right value. Right? Just go do it and let the system figure out what's happening. And things are easier with context, right? You can catch up quickly whether you are an engineer jumping out to an outage that that has been going on for several hours and someone has to go to sleep and you just woke up and you have no idea what's happening, and you just say, okay, well, here's what they've done. Or if you're a new member of operations team, when you get an alert, you can say, okay, well, what did we do the last time we got this alert? What was the flurry of activity, right? And someone in the crowd is like, well, you have runbooks for that. Someone filled that out last time. No, they didn't. And so, yeah, in that vein, you're able to retrace your steps, or more importantly, someone else's that, that they may or may not have done consciously to resolve a problem. And then you also get this benefit of being able to communicate changes and communicate about changes in a natural and sort of efficient way, right? You don't have to send out this mass email that says, here are the steps that I took in order to achieve something. You just say, look, here's the time window, here's all the information about what I did, here's basically the log, and even if you don't do that, someone can just go see what you did, right? And that goes a long way to establishing the sort of the trust that Catherine talked about, transparency and being able to go back and see what someone did or see it as they're doing it. Goes a huge way towards establishing that, because sort of everything then happens in the open. You don't have to sneak changes across. You don't, like, it sort of builds up this culture of just doing what you got to do and knowing that if someone needs to find out what you did, they can just go look. And then you end up in this happy utopia where everyone trusts each other, and everyone knows what everyone did over the weekend, and you don't have to wait for Jimmy to show up from the gym to tell you what happened. It's just all there. And obligatory, we're hiring because what I just described is a ton of work. And that's all I've got, save for questions.
Thank you, Mike.